Hola, buenas tardes. Me llamo Tomás. Hablo un poco de español, un poco más que Robert, pero igualmente que Robert entiende, hablaré en inglés. Okay, so my name is Thomas Steiner. I'm from the Chrome DevRel team, like everyone else here who is a Googler. And today I want to talk to you about AI. And who thinks, as we have just seen, AI and DevTools is pretty cool? Yes? That's quite a few people. But who thinks AI in the browser is actually even cooler? Yes. Okay, sorry, guys. You just asked a question about the AI model, Gemini. What they were showing is Gemini running somewhere in a Google Cloud. What I'm showing now is Gemini Nano, which is Google's smallest AI model, running locally in the browser. And we actually put AI in the browser. So let me show you how it works. I have example.com open here. So this is really just the proxy. We don't need example.com. We need the DevTools console here. And we put AI in the browser. And how do you see that? Well, you just open self.ai and you see, oh, AI is actually a thing now in the browser. So let me actually open it and we can see what's there. We can open it, and we can see in AI, in the new namespace AI, on the top level, we now have different things. We have a language detector, we have a language model, we have rewriter, we have summarizer, we have writer. And today I want to talk to you about the language model. And let me actually show you what the language model does. So language model gives you access to, as I said, Gemini Nano running directly in the browser. There's no cloud, there's no request to a server, there's no tokens, API, whatever, sign up, something. It's really just locally in the browser. So let's start with a little bit of a demo. I need to clear the console frequently because I've zoomed in so much. So is the font size good for the people in the back? Can you see when I type something here? Yeah? Okay, cool. So let's start with self.ai.language model. And we can see we now have an AI language model factory. If you open it, we see that we don't see a lot because it's a factory. So we need to do something with it. And because it's a factory, we can check its capabilities. And capabilities is actually a function. Everything here is asynchronous, so we need to await the result. And if you now execute this, we can see that now we have an AI language model that has certain capabilities. So let me actually expand this a little bit so that we can see what's going on here. We have a property called available, which means this language model is available readily in the browser. I can use it right now. The cool thing about this is it's dynamic. So the first time any application on the web requests this, the browser will start downloading the model. So in the beginning, it will not be available. It will be available after download. So the availability will be after download. But once you have downloaded it, for the first time, any application, all the other applications that want to use this AI model can use it. So it's readily available. The rest is AI stuff. So we have a default temperature, which is 1. We have a default top K, and we have a maximum top K of 3, and maximum top K is 8. So you know, if you deal with AI models, this is the parameters or some of the parameters that you can tweak to change how the model will behave. So now that we have looked at the capabilities, let's actually do something with it. So we need to get a session with the AI model running. So I instantiate a new session variable as await self.ai.language model. And instead of capabilities, I have create. And when I execute this, I now have a session going with my AI model. Oops, not session storage, session, this guy here. If I open it, you can see a number of things here that are important for this session. So we have a maximum number of tokens, which is 4,906. We have a default temperature, which is 1. Because this was the temperature that the model has as default. We have tokens left. Well, all the tokens left are the ones that yeah, I've used, so none so far. So token so far is 0. I haven't done anything with the model yet. And we have the top k of 3 because this is the default value. All right, so what do you do with the session now? Well, you prompt the AI model, and this is exactly what we will do now. So we will call the session.prompt method, and we can ask the model anything like, what is the capital of Spain? Question mark. Whoa, what's going on? And we will be very polite. We will ask it, please. And again, this is asynchronous, so we need to await the result. And now we're making an actual question, a prompt to the AI model. So let's see what's happening. The model thinks, and hopefully we will get a response back. The capital of Spain is, ta-da, Madrid. And the model is right. And you can see already this is formatted in Markdown. So if you read Markdown, this will make sense to you because the double asterisk makes the Madrid bold. And then we have a new line that just terminates the response. And this is it. Now we can talk to an AI model. And it's a session, so we have context. So we can continue and ask the question like, how many people live there? And there, because we have a session going, will now hopefully be interpreted as Madrid. So let's see what's happening there. The model thinks, and hopefully we get a response, and is as of July 1st, 2023, Madrid has a population of 3 million something. This makes it the most populous city in Spain and the 5th most populous city in the European Union. I don't know that. I'm not sure if that's actually true. Anyone here have a gut number? Is this number somewhat correct? Yeah? Okay, cool. So you can see already where this is headed. We have a conversation with the model. And that's kind of really cool because, well, it's a session and it's something that continues the conversation. But of course, at some point, we want to start fresh. So we need to destroy the session. And this is exactly what we can do with a session. So if you look at what other things I can do with a session, I can clone it. Why is this useful? Well, because sometimes I want to initialize a session that has certain information with it. So I can tell it, for example, to be a friendly support bot that should never, I don't know, answer a question about X, for example. So if you have a topic in your company that you can't talk about, you can brief the session, tell it, hey, everything that you tell, don't tell anything about X, for example. You can do this once, and then for all the other sessions that you run, you can just clone the existing session, so you don't need to initialize each session fresh each single times. You can count the prompts, so the prompt token. So we can actually do this. Let's have a look at this and say, like, how many tokens will my prompt be? So I can say, like, when was Madrid? Oops, typing is hard if you're a little nervous. Madrid founded. And asking this will cost me 14 tokens. I can also look at my session tokens left and tokens so far. So I can see so far I've consumed, well, I have 3,998 tokens left. And I can, of course, also see my tokens so far. So far I have consumed 98 of the tokens that I have. Why is this important? Well, a session has a running window of tokens, and every time you ask it, this window becomes a little bit smaller, and at some point you will have exceeded your session memory, if you will. So at that point, the oldest conversations will be thrown out of the session, and the model will sort of, like the session with the model will sort of forget what you asked it. And then, yeah, it will just continue the sliding window of the session memory, if you will, that it can hold. Okay, now we can destroy the session, for example. And from there on, we could start fresh. All right, so this is the prompt API. I will show you later how you can use this, how you can play with it yourself. I want to just very, very briefly show you some of the other APIs that we have in the self.ai namespace. Something important to notice about this, everything here is in flux. So if you look at the options that you have right now, the rewriter and the writer APIs currently are broken. So it's, as I said, something that is still heavily in development. So I can show you the writer and the rewriter APIs. But what I can show you briefly is the summarizer API. And that's a very useful API as well because, well, it summarizes things. As before, we have capabilities and we have a create function. So let's just very briefly run the capabilities function just to show you what is in there. And we can see, well, it only has the capability of being readily available, which is great. So we can use it. So now we can say we have a new summarizer as await self.ai.summarizer.create. And now this summarizer can do stuff for us. So you can see we have different things that we can do with it. And the easiest, of course, is we can summarize something with it. So let me just get a random text, for example, this text here from the example.com page, which reads, let me zoom in here as well. This domain is for use in illustrative examples in documents. You may use this domain in literature without prior coordination or asking for permission. So it's an example text, but we can summarize it. And I need to await the result. And, ooh, what did I do? Oh, I didn't close the... Yes, I have a new line at the end. Okay, so let's do this now. And now it's thinking, summarizing, and we will hopefully get a result pretty soon. Yes. So now you can see it has summarized. So this is kind of, again, markdown syntax. You can see here the little asterisks. This is for bullets. So it has summarized the text into various bullet points. So you can see here there's new lines after each bullet point. And yeah, this is a summarization of the text here. So very useful API as well. You can fine-tune this. You can say how you want to summarize. You can say, I want bullet points. I want the key points. I want the TLDR and so on. So that's a pretty cool API, very useful in many cases. And you can imagine already why someone like, I don't know, a newspaper might want to use this so that they can just summarize for you articles so that you can read them more quickly. You can decide very easily what is the thing that you want to read, what is the thing that you want to skip. Another API that I want to show you very briefly is the language detector. It detects languages, so no big surprise here. And I just create one. So const detector equals await this. And then we have the detector. It can detect. And now we can say hola, ¿qué tal? And you can see that you don't see anything because we need to first expand it. So it gives us an array. And if we open the first entry, you can see that it's 99% sure that this is Spanish. We also have a translate API, which is also pretty cool. The translate API is not in the AI namespace yet, but we're working on it. And yeah, this is, of course, a very useful API, language detection in combination with translation. So if you have user-entered text, you don't know what language it's written in, you can run it through the language detector API and then feed it into the translator API. So let me show you the translate API. So we have translator equals, and this is directly still living on the main AI window namespace, not AI, but as I said, we will move it into the AI namespace, and we can create a translator that can translate from the source language, let's say English, oops, and it should translate into the target language, Spanish. And I need to await, something that is always easy to forget. And now we can have the translator translate something. And I want to translate from English to Spanish. So I can say, hi, my name is Tom, and today I want to show you AI running right in the browser. And we need to await the translation. And boom, hola, mi nombre es Tom, y hoy quiero mostrarte que IA, it has a mistake here, probably that's not the perfect translation, so AI, IA, se ejecuta directamente en el navegador. And again, this is no network, this is all running locally based on AI models that we have put into Chrome. So now that I've seen a number of these APIs, let me actually go to some slides where we can see, well, where this is headed, what you can build with this. And this is from a big event that we had recently in Sunnyvale in California. It's the Web AI Summit, so you can see the little logo here, the Web AI Summit. So this is a presentation that I gave there so that people can see a little bit what we can do with these APIs. And it's titled Lessons Learned from Being Customer Zero of Chrome's Built-in APIs that you've seen just now. What do we mean with customer zero? Well, the customer zero is a customer that is, well, the 0th customer, someone who tests the feature a very first time that it is testable. And typically at customer zero is also disconnected from the team that has implemented it. So I'm from developer relations. The Chrome AI team has actually implemented the AI APIs in the browser. So we have a disconnect here. They implement, we can test, so we are the customer zero. And this allows us to give unbiased feedback. So whenever I see something that is like, oh, this is inconsistent. So you have seen all the APIs that I showed you, except for the translator API, have this create and capabilities pattern. So if I see there's some inconsistencies, I would go and tell the engineers and say like, hey, there's some inconsistencies there. Maybe you want to make everything aligned. So this is customer zero. And now we need to go from an idea to a prompt. And I showed you this before with the prompt API, but like, what can we do with this? First, we need to come up with an app idea. And something that I, as a non-native speaker of English, always do is I go to Google and I search for synonyms of words, because sometimes you just need inspiration. So synonyms for the word funny. And then you go to Google and enter synonyms for funny, and then you get some results here. So that's a good idea, actually, something that you can outsource to an AI, because the AI can have additional context. So you could say like, yeah, I need a synonym for a word, and I don't want whatever, this particular word, because I want to avoid having two same letters in the same phrase, so no alliterations, for example. Sorry, no alliterations, for example. So this is where AI can become useful. So now, once you have come up with this idea, you need to come up with a prompt. Some putting things into context, you have probably used something like ChatGPT, you have probably used something like Gemini, you may have used Claude. So some of these really, really large AI models that run somewhere in the server on the cloud. This is a little different. So Gemini Nano, as I said, is a really small local language model. And it's kind of paradox. It's a large language model, but it's a small large language model. So this for putting things into perspective. Don't expect the quality level of like the really, really large LLMs. But yeah, this is a small, locally running LLM that has certain challenges that I will go into in the next couple of slides. We have a Chrome API playground, so you can play with all the different APIs. And this is the prompt API playground. If you want to test it, this is the URL. But again, you can't really test it yet because I haven't told you how to use those APIs. But if you wanted to come up with like the prompt to work with this, the prompt API playground is a good idea. So I just start with this prompt, create a list of synonyms for the word happy. And then, of course, later on, I would use this more dynamically, make it more dynamic. But for now, I can just use this and try it. And if I do, the thing responds with a list of synonyms. So you can see here, sure, here's a list of synonyms for the word happy. And then a number of words, joyful, cheerful, glad, yada, yada. I asked it for the list. I didn't ask it for this friendly opening text. So that's something the model typically tries to do. It makes it sound human. But in this case, I actually just want the list of results. I don't want the synonyms. I don't want the thing to be friendly. I'm going to be friendly to it because you never know with AI. Once it becomes too intelligent, it will strike back. So we don't want this text. How can we get rid of it? Well, the easiest what we can do is we can just tell the model, and in this case, create a list of synonyms for the word funny, and I would add only respond with the list of synonyms. Do not respond with text before or after the list. And if I do that, it actually helps. The model is smart enough to make sense of this. So you can see I now get only the words back that I want. So the text from before is gone. I just have the list of synonyms. Something that is important here, I need to reinitialize the session because I told you before, the session keeps the context. Of course, we don't want the context. We want the session to be fresh. So you need to start with a fresh session. The playground has this red button here, reset session. They can exactly do what it says on the tin, reset the session. All right, so this has worked. But trying a little bit more, we can see, oh, there's a problem actually. And this is something that these smaller models sometimes do. They have a tendency to, just sometimes mixing things up a little. So we have a duplicate there. And of course, you could locally on the client side deal with it. But we can also try to tell the model, hey, make sure that only each synonym appears once in the list. And with a fresh session, actually, we can see this has worked now. Now I have a list of just the 3 unique synonyms here for my test word. All right. Some of you might be wondering, well, why does he not just ask for JSON? Well, the reason is JSON is a not streaming-friendly format. If I want a JSON response and I want to make sense of it, I need to wait until it's there completely. And I sort of skipped over it a bit in my presentation, but I can very briefly show you the Prompt API playground in action. So if you do this, give me a list of synonyms for the word happy, please. And I press the button. You can see it's starting to generate the response. And, well, it was very fast, but you can see it's streaming in the responses. So there's actually 2 methods that you can use, the prompt one and the prompt streaming one. I didn't show you the prompt streaming one because it's a little bit more involved to program. But there's a streaming response. And if I want to make sense of a JSON response, I need to wait until everything is streamed down completely. But you can see already, for me as a human being consuming this list, it is actually useful to see the streaming results come in because I can already start processing the synonyms as they come in. So if we go back to the slides, that's the reason why I don't ask for JSON in this particular case, because I want maximum performance. I want to get the results in a way that is consumable as soon as possible. In theory, of course, it would work. I can tell the model to respond in JSON, and it would work. But it's a little bit, for this particular use case, not the best method. All right, now it's time to come up with an MVP implementation, so a minimum viable product that just barely shows how it works. And this is it. It's a synonym finder. You can see I need synonyms for the word funny. There's a button, and then you get some words back. So if you were actually to run this, you would see it gives you some bullet points with the synonyms, and then you also have the possibility to expand and see the raw response. So this is the backup slides in case of anything going wrong. As I said, this is all things running sort of on the very bleeding edge, but this is the actually live product. So let me show it and see if it works. So let's go for happy and then suggest some synonyms and let's see if it works. Oh, interesting. So you can see this is just a couple of weeks after the event, but now the model has internally changed a bit. So you can see it sort of mixes different words together. So that's not great. So that's something in the model that, just is something you need to deal with. So if you look at the raw response, this is the prompt that I sent it. you've seen it. Well, let me actually increase the font size a bit. This is what I mentioned before. But now you can see in the raw response, it has changed the format. So now it no longer responds with markdown bullets as it did before, but now it's using them comma separated. And because in my front end, I expect the code to actually return markdown bullet points, which this new model version does not anymore. Yeah, it sees the comma separated list, which is of course also nice. But yeah, like this is some of the things. You will work with AI and you will see AI as a moving target. So sometimes if you think everything is working fine, as it was when I showed this the first time, now with something in the model changing or just your prompt changing a little bit, you can have these kind of situations where just everything sort of seems broken because technically, well, it's not broken, but the format has changed. So you need to harden your processing of the prompts responses as well. But yeah, you can see it has worked in theory. It's just not as beautiful as it could be. But yeah, for here you can see it has worked in the past. This is not faked. This actually has worked in the past because the model would return the bullet points very beautifully formatted. But let me show you how actually this is working now internally. So we have, as a step 4, the implementation. And we have a very simple get prompt function. We give it a word that it then just dynamically here inserts into the prompt that we came up with in the previous couple of slides. So not super interesting here. And then you can see, well, we want to only get one particular word. We don't want the user to enter sentences. So what I'm doing here, I'm only accepting letters, and I'm only accepting the very first. So you can see here I'm splitting at the space or any kind of space character, and I'm only accepting the very first word. So I really want it to be a very simple application. One word, and then synonyms for that word. Not an entire sentence or something, really just something very simple. You've seen this before on the command line, so I'm not going into it a lot. Apart from the prompt streaming part here, so you can see we have a stream that we get from the API. And that's what I said when I said it's a little bit more involved, so not as easy as before to show on the console. With this stream, we can iterate over the stream and get the responses chunk by chunk. And this is what you've seen streaming in. Every single chunk contains part of the response. So each item is a new line. Well, it was when I tested. Now it's possibly also split by a comma. So you can work this into the logic here if you wanted to. And this is something that you will definitely need to do in your applications. You will roll this out to your real users, and something will at some point change or break for someone. So it's always important to have some sort of feedback. So you've seen in the Chrome DevTools talk, there's the thumbs up, thumbs down feedback mechanism that can say, oh, this is not great, this is maybe a little bit broken. And here you, as a security measure, also need to sanitize the output. In this case, you don't want the model to respond, for example, with a script tag, which is something that could happen if someone is evil and somehow tricks your model into responding with HTML. It would be really hard in this particular case, just because my prompt is only accepting one word. But prompt injection is something that you need to think about. So in this case, my simple sanitization step is to exclude anything that is not a letter, and then just throw everything away, which is why in my code, you saw the commas, they were just removed, so all the words were chunked together. Again, this is because the output format has changed. But yeah, it was working by just splitting on new lines before. And then we just remove empty lines, which is sometimes something that can happen when I'm streaming. All right, and then I have the result. I can then put it into the inner HTML of my output. Here's a list of the synonyms for the word, and then I have the word, and then I just create a list and show it on the screen. So that's what we have seen here. Well, it's a one-element list, and then we have the comma-separated words chunked together because, well, I've said it before, the output format has changed. But yeah, this is how it was working before and how it will probably work if I just try a different word and the AI comes up with the usual format of responding in Markdown with bullets. this does work. And let me show you the screen recording of how it was. I click the suggest button. And you can see, like really letter for letter, these words stream in. So if you paid attention, the words stream in really letter by letter. Let me show it again. So now I try new word, lucky. Press the suggest button. And you can see, as the model is thinking, coming up with its response, I can see like really word by word, letter by letter, how the model comes up with its suggestion. And again, this is, for this toy example, of course, completely useless because, well, we could just have waited for the entire list to show up. But like, imagine you have something complex and you have to wait for the entire response to be generated before you can see something. In many cases, this would not be something you would be willing to wait for. You would typically want the response streaming in. So from the start, think of, oh, this is going to be complex in the future. So streaming from the start. Let me move on. Now it's time to optimize the app. Until now, we had an MVP. Very simple, it did the job, but it's not great. Why is it not great? Well, it has a performance issue. And again, this is a toy example, so it's not super interesting or super important. But what is the performance issue? Let me show you in the Chrome DevTools. I open DevTools here, and in DevTools, there's a cool feature called the rendering panel. And if I show the rendering panel, I can go there and activate paint flashing. And whenever the browser paints something, it will now show you by highlighting the area where it paints with a green square or rectangle. And this is my output element. And if I press suggest now, look at what's happening. So everything gets repainted constantly. And you can see if you pay attention to the area here with the output, this is flashing like crazy. Well, why? Because every time a new chunk comes in, the browser needs to repaint everything. Toy example here, completely negligible. Is that a word? Yeah, negligible. But in practice, if you have something that is really big with code blocks and everything, like your classic hey, help me create a function that does this would not be acceptable. So you would shoot yourself in the foot if you were to repaint on every single new chunk that comes in. So how can you optimize this? With some improvement to the HTML. Is it playing? Yeah, it's playing the same one. So what is the bottleneck? Well, the bottleneck here is the inner HTML. We can do better. We can do a lot better than using inner HTML. It's, for an MVP implementation, the easiest thing you can do. But yeah, not something you would actually want to do. And here you can see why. Because I'm in this loop creating the inner HTML and resetting it every single time. You could be wondering, well, why does he not plus equals? So why does he not take the existing inner HTML and then just append to it? It's exactly the same performance problem. The browser would still repaint everything. So there's no recycling of what is already on the screen painted. It's repainting everything. So think in practice, inner HTML is a very expensive function if you run it in a loop, as I'm doing here. So how can we optimize it? We can optimize it with a very, very old API in the browser. Turns out browsers have handled streaming HTML since forever. And in the browser, there's a document.implementation.createHTML document function that gives us a document fragment. And with this document, we can then just use the good old document write API and write into this. You can see here I'm writing, here's a list of synonyms for the word, and then the word that was dynamically entered by the user. And then I start my list element here. So unordered list, first list item. And then I append this to my document body. And then, well, that's a document, right? In my loop, rather than using inner HTML, now I just continue writing to this already existing document fragment. And in the end, I just need to write the closing UL and the closing div tag. And now, if you look at the same debugging output from DevTools again, hopefully the performance issue is gone. So let me play this video. Pay attention to what's happening in the output panel. I just enter a new word. humorous, I press suggest. And you can see now the browser really only ever paints the new stuff. So you can see very clearly only the new stuff gets painted. Everything else just stays on the screen. Toy example here, it's not really important, but if you build something for production, definitely this is a performance trick that you need to pay attention to. Yep. Let me continue here. So what you've seen is from an idea to a prompt, MVP implementation, optimization of the application. So now you probably want to know, how can I try this? And the good news is we have documented all of these APIs on developer.chrome.com, docs, AI, built-in APIs. And this is bleeding edge. So everything what we do is still in flux, which means if you have feedback, please give us the feedback, help us shape these APIs, make them work for you, for your use cases. If you want, all of these resources are available online. The demo application, the early preview program that you can join. So there's a very simple form, Google form that you fill out. You tell us what you want to do with AI, and then you're part of the early preview program, which will give you access to the built-in AI API docs. And from there on, you can start playing with these APIs right in the browser. And with that, thank you very much for listening. I think I overran a little bit.
So, is it possible to ask the AI to summarize the inner text of a web page without pasting the text on the prompt? We have two. That's good.
Yes. Who asked the question? Oh, here. Yes, so you can just pass to the summarizer API the document element that you want and access the inner text. Inner text is the one that keeps the formatting, keeps the rendering, but throws away the formatting. So it will still keep, for example, the paragraphs. Oh, no. It will keep the paragraphs, but it will throw away the colors and the formatting and so on. So if you just pass it, let's say document get element by document get query selector article dot inner text and pass it to the summarizer, this would perfectly work.
Share the specific. You have to specify the ID or the element that you want to take, right?
Yes, you need to give it some reference so that the summarizer knows what it needs to summarize. In practice, it's not that simple because you don't know the length of it. So the summarizer has, like the prompt API, a content window length. So right now, internally, the summarizer is sort of built on top of the prompt API with a special internal system prompt that tells it to summarize. And you can't exceed 4,096 tokens. So you need to check how long is my text. And then if it's too long, you need to split it up into, like, for example, paragraphs or like just smaller sections that you can then summarize one by one. So yeah, this is essentially what you can do in this case.